let's discuss on gradient of a curve. When you are asked to evaluate the gradient of a curve, all what they are asking us to do is to evaluate the y dx at that particular point. So let's take, we have these three questions: gradient of a curve of different forms of equations of curves, and we have at points, and we have various points at which you are going to evaluate that gradient. So number one, we have that y is equal to 2x divided by x squared minus 5. Now, this is u and this is v. So our u is 2x and our v is x squared minus 5. Okay, this is quotient rule. Let's apply quotient rule. Then the u dx of 2x is 2 and the v dx of x squared is 2x. So applying our quotient rule, we have that the y dx is equal to v du dx minus u dv dx divided by v squared. Therefore, our dy dx is equals to x squared minus 5, because that's our v. Our du dx is 2 and our u is 2x, and likewise our dv dx is 2x divided by x squared minus 5. Now let's open up the brackets. We have 2x squared minus 10 minus 4x squared. So this will give us minus 2x squared divided by x squared minus 5 all squared. So this gives us minus 2x squared minus 10 divided by x squared minus 5 squared. Now we are asked to find the gradient of the point of the curve at point 2, minus 4. So at 2, minus 4, that means we are looking for the gradient. The gradient of the curve is dy dx at x is equals to 2. So therefore, wherever we see x, okay, we will substitute 2. So substituting x now, so we are going to say dy dx at x is equals to 2 is minus 2 into 2 squared minus 10 divided by 2 into 2 squared minus 5 all squared. And simplifying this, we have our answer to be minus 18. So the gradient of the curve at 2, 4 minus 4 of the equation of y is minus 18. And let's look at the second question. The second question says, find the gradient of the curve of this equation. Find the gradient of the curve of this equation. That's y is equals to 2t raised to the power 4 plus 3t squared plus 3t raised to the power 3 minus c plus 4. So y is equals to 2t raised to the power 4 plus 3t squared minus t plus 4. And we are after the point at 0, 4 and also 1, 8. So the first thing to do is to evaluate the differential, that's the y dt. So when we differentiate this, we have 8t raised to the power 3 minus 6t minus 1. So at the point 0, 4, at point 0, 4, we are going to the gradient of the curve is dy dt at x is equals to 0. Okay, so which is equal to 8 into 0 raised to the power 3 minus 6 into 0 minus 1, and this will give us minus 1. And at 1 comma 8, the gradient of the curve is the differential at x is equals to 1. Okay, so where I'll see x, we will substitute 1. Sorry, at t, this should be at t. Likewise, this should be at t. So where I'll see t, we substitute 1, so that is 8. Y is power 3 minus 6 into 1 minus 1. And this will give us 8 minus 6 minus 1. Okay. Eight minus 6 minus 1. It's 2 minus 1, and that will give us 1. Now, let's consider the final problem. It says we should evaluate the gradient of the curve of y is equals to 3x raised to the power 4 minus 2x squared plus 5x, okay, minus 2 at the point 0 comma minus 2 and at the point 1 comma 4. 1 comma 4. So therefore the first thing we evaluate is the y dx, and this will give us 12x raised to the power 3 minus 4x plus 5. So the gradient at 0 comma minus 2 is equal to dy dx at x is equals to 0. So therefore this will give us 12 into 0 raised to the power 3 minus 4 into 0 plus 5, and this will give us 5. Likewise, the gradient at 1 comma 4 is equal to the dy dx at x is equals to 1. So wherever we see x in dy dx, we substitute 1. So this will give us 12 raised to the power 3 to 1 raised to the power 3 minus 4 into 1 plus 5. And this will give us 13. So the whole essence of evaluating gradient can be done by first evaluating the dy dx and therefore making substitution at that value of x.